So today's topic is interference. This comes under optics plus 2 physics. Okay, we have two light sources. This is source 1 and source 2. And these two light waves arrives at P. So there is an interference. Now we have, it can be constructive interference or destructive interference. So first we will define what is interference. The phenomenon of addition or superposition of two light waves which produces increase in intensity. So brightness can be increased at some points and decrease in intensity at some other points is called interference of light. So it can be a constructive, when two lights meet at a point, it can be constructive interference or it can be destructive interference. So the very simple example is, suppose we have one wave like this and another wave with the same phase, then this is constructive because this 0, this is 0. If this is high, this is also high, so both will get added together. So this is a constructive interference. The magnitude wise will increase. You have destructive interference also. Destructive means, suppose for another example, this say this is magnitude 1, this is magnitude minus 1. So what will happen is, if you have out of phase, out of means 180 degree out of phase, okay, when this goes 1, this goes minus 1. Therefore, if you add both, it will be 0. So the resultant of this waveform, this goes negative and this goes positive. When you add together, the resultant is no output. So it is darkness, no light. So this is a case for destructive interference. So we will see a small derivation on what happens with the two sources of light arriving at a point, whether it is constructive or destructive, or what is the basic condition for constructive interference or for destructive interference. Okay. Now from source 1, let the light wave equation be A1 sin omega t, that is A1 is the amplitude from this source. Then from source 2, it has the amplitude A2 sin omega t plus pi. So A1 and A2 are totally different. This can have some amplitude, this can have some amplitude. And omega t, that means Y2 is leading by angle phi, that is omega t plus phi. These are all, this is the two waves from source 1 and source 2 arriving at point P. So now we have to apply superposition principle. So superposition principle is y is equal to y1 plus y2. So now y1 we have a1 sin omega t, you write down. y2 is a2 sin omega t plus phi, you write it down. Now if you add these two, you will get y is equal to capital A sin into omega t plus theta. The proof for this I will give at the end of this derivation. I will derive and tell you how you got this. Okay. So if you add y1 plus y2, you will get a sin omega t plus theta, where a is equal to square root of a1 square plus a2 square, that is this a1 square plus a2 square plus 2a1 a2 cos phi. Cos phi is the angle, this angle phi. Okay, under root, this is a. And then we have theta. This theta is equal to tan inverse of a2 sin phi divided by a1 plus a2 cos phi. So at the end of this derivation, we will see how we got this results. That means, once again I repeat, y1 is the optic output from source 1, y2 is the optical output from source 2. Both are interfering at this point P. So we can apply superposition principle. So y is equal to y1 plus y2. So you're adding this term and this term together, getting this term. The proof for this will be said in the end of this derivation. Okay. Now we have this equation. That means the output is y, which is equal to a sin omega t plus theta, and we have defined for a. What is a? a1 square plus a2 square plus 2a1 a2 cos phi under root. Now you have a term cos phi. So when will be the cosine will be maximum? So cosine when will be maximum? I will draw the waveform. Okay. Now this is sine wave. and the cosine wave starts like this. So this is 90 degree, this is 180, this is 270, and this is 360. That is, this is cosine waveform. Cos 0 is 1, positive value, whereas cos 180 is minus 1, negative value. Okay, then cos 270 is 0. Okay, and then you have at cos 360 it is maximum. So I want this amplitude to be maximum. So we don't want at 90 and 270. Why? Cos 90 is 0, therefore this term will vanish. Okay, this overall term will vanish. But when cos 0 is 1, if you apply phi is equal to 0, cos 0 is 1. That means you have this term plus one more term, 2a1 a2. That will be the maximum amplitude. So in the other case, when it goes at 180 it is minus 1. So this value will become minus. So the answer will be a1 square plus a2 square minus 1 into this term will be minus 2a1 a2. That means this values get added and this value is subtracted from that. That will be the minimum. So when it will be maximum? It will be maximum at 0. Afterwards it reaches maximum plus 1 at 360 degree. That means 0. This is 2 pi. Plus or minus 2 pi. 2 pi and multiples of 2 pi. So that's what I told you. So when this value becomes 0, phi is 0, cos 0 1, a1 square plus a2 square plus 2a1 a2. Now this can be written as a1 plus a to the whole square. That's what is written here, which is a max. And we have written when it happens 0, 2 pi, 4 pi, like that. And we have put minus also. Why? Because cos of minus theta is equal to cos theta. That means whether it is negative or positive, it is going to have the same value. So we can write it as plus or minus. Okay, so this goes up to infinity. So that is the case for maximum. Now next, we want minimum. I told you minimum means this value should be negative. So we have minimum, the cosine wave minimum is 180. 90 is 0, 180 is minus 1. So when you put minus 1, this will be minus. So a1 square plus a2 square minus 2a1 a2. That means the term can be written as a1 minus a2 the whole square. That's what is written here. And the whole thing under root. So this happens, minimum value, amplitude minimum will happen only at phi is equal to plus or minus pi, 180 plus or minus 3 pi. So we have shown you the diagram. So for the cosine wave we shown already. Okay, the minimum values we have shown already. So it starts here, goes like this, then like this. So this is 90, 180 it is minimum. Then after this, after 360 degree, that means this is pi plus you add one more 2 pi. So totally it will be 3 pi. That's what is written here. So plus or minus pi plus or minus 3 pi. Why we put plus or minus? Because cos of minus theta is cos theta. Therefore, you will get minimum at this point. So at these values, pi is equal to plus or minus pi plus or minus 3 pi, cos will take minus 1. Therefore, you will have minimum. So this will be minus 1. So we can write it as a1 plus a2 the minus a2 the whole square under root. This will be minimum. Okay. So now we have one more term. The intensity at this point. We are interested in intensity at this point is directly proportional to a square. So that means a max we have. A max is this much, maximum value. So if I want intensity because of a max, then in that case it will be, so intensity will be directly proportional to this case a max square. So a max the whole square. This is for constructive interference. Therefore I becomes a max. If you square this, you will get a1 plus a2 the whole square. Okay. This is for amplitude maximum, intensity maximum. Okay. Now we want destructive interference. So in that case also you apply A min. Okay. A minimum. The intensity will be minimum. Where? In this condition. So A minimum square. So A minimum is this square root. If you square that, it will go. So A is equal to A1 minus A2. So if you take square, the square root will go. So you will have A1 minus A to the whole square. Okay. So that's about intensity at this point. So we have A min square. A min we have seen now. So if you square this, the square root will go. You will get A1 minus A to the whole square. This is for destructive interference, and the intensity because of that is directly proportional to A1 minus A to the whole square. So that's all about interference due to two light sources meeting at a point P. It can be constructive and it can be destructive. Constructive, we have the relation amplitude maximum is A1 plus A2 the whole square under root. Of course, this square root and square will get cancelled. Now, the intensity is directly proportional to amplitude square. Therefore, A square. If you square this, the square root will go. Therefore, you will be having A1 plus A2 the whole square. For destructive interference, we have this minimum, amplitude minimum. For this, if you square that function, the square root will go, it will give you A1 minus A to the whole square. That is the intensity at the point P. So that's all about interference due to two light sources, which has equation A1 sin omega t, and the another light source which has the equation A2 sin omega t plus phi. It is leading by angle phi. Now we will see the proof for this derivation, this equation. That means we have already told you y is equal to y1 plus y2, and you will get this, and this can be written as this with this and angle theta. So we will derive for that. So you go through the trigonometric derivation thoroughly. So straight away you need not write that proof in the exam paper, but you should remember that straight away you can make use of this equation, and you can explain the concept behind interference. Okay. Now we will see the proof for that formula, the equation. Okay. So let y1 is equal to a1 sin kx minus omega t. Another way, a2 is equal to a2 sin kx minus omega t plus pi. Okay. Now y is equal to y1 plus y2. That is y1 is this a1 sin kx minus omega t plus a2 is this term a2 sin kx minus omega t plus pi. Now kx minus omega t you treat it as a plus phi you treat it as b. So it is of the format a plus b. So sin a plus b is sin a cos b plus cos a sin b. So you write this term as it is plus a2 into sin a cos b plus cos a sin b, that is sin phi. This is equation 1. Okay. Now we define two terms. Let a cos theta is a1 plus a2 cos phi. Okay. A sin theta is a2 sin phi. This is equation 2, equation 3. We will be using these two equations later on. You just we are redefining it. Okay. Now from this equation we have a1 sin kx minus omega t first term plus this a2 is brought inside. So a2 sin kx minus omega t into cos phi plus a2 into the second term. So a2 cos kx minus omega t into sin phi. Now sin kx minus omega t, here also sin kx minus omega t. These two terms are common. You take it outside. So inside you will be having a1, and for the second one a2 cos phi. That's what we have written here. And the remaining term a2 cos kx minus omega t into sin phi is written as it is. Okay, this is sin phi. So a2, this is a2 sin, okay, a2 sin phi cos kx minus omega t. Okay. Now y is equal to sin kx minus omega t, this term. a1 plus a2 cos phi we have defined already. a1 plus a2 cos phi, we are writing it as a cos theta. Okay, a cos theta. Then you have the second term a2 sin phi cos kx minus omega t. a2 sin phi is nothing but a sin theta. So this term can be written as a sin theta into the second term cos into kx minus omega t. Cos kx minus omega t. So this term and this term we have a as the common. You take a as the common term. Inside you have sin kx minus omega t cos theta plus cos kx minus omega t into sin theta. This is of the form sin a cos b plus cos a sin b. So this can be written as sin a plus b. So a into sin, a is kx minus omega t and b is theta. Therefore y is equal to a into sin kx minus omega t plus theta. So we seen that y is equal to a into sin kx minus omega t plus theta. Now we will add equation 2 and 3, that is second equation square plus third equation square, and then we are adding second equation square. So this will become a square cos square theta. This side it will become a1 plus a2 cos phi the whole square, that was written here. And this is a square sin square theta. Right hand side a2 square sin square phi we have written. We are going to add. So a square is common, sin square theta plus cos square theta, the value is 1. This is a plus b the whole square formula, a1 square plus 2a1 a2 cos phi 2ab plus b square a2 square cos square phi. For this a2 square sin square phi. So this value is 1. Therefore we have only a square. And here again in these two terms a2 square is common. So sin square phi plus cos square phi is 1. Therefore we have only a2 square. So the right hand side will be a1 square plus a2 square plus 2a1 a2 cos phi. Now this is a square. Therefore a is equal to square root of a1 square plus a2 square plus 2a1 a2 cos phi. So this is the equation we want to prove, and we have proved it. Next we have to prove the tan theta. So we have third equation and the second equation. So third equation divided by second equation will give you the tan theta formula that we will see now. Now we are interested in finding out the angle theta. So we have the second equation and third equation, we have already defined it. So third equation divided by second equation, that is third equation by second equation. Third equation is what? A sin theta divided by a cos theta is a2 sin phi divided by this term a1 plus a2 cos phi. A gets cancelled, sin theta by cos theta is tan theta. So you will be having a2 sin phi divided by a1 plus a2 cos phi. So therefore theta is equal to tan inverse of a2 sin phi divided by a1 plus a2 cos phi. This was the result we are expecting for the derivation. So this is the proof for that equation. So we have the amplitude, this we have proved, and theta, this also we have proved. So now you just see the starting of this derivation. We have seen y1 is equal to a1 sin kx minus omega t, and y2 is a2 sin kx minus omega t plus phi. Now if omega t equal to 0, so this term is 0, here also 0, we will get y1 is equal to a1 sin kx and y2 as a2 sin kx plus phi. But in the derivation we were using omega t. So what you do is, in the place of kx, substitute omega t. It can be anything, theta 1, anything. But kx you substitute omega t. So this will become omega t. Here also it will become omega t. That means now I can write here it as omega t. And here also omega t. So we started deriving assuming the equations like this. But the basic proof for that trigonometric relation is this. Hope you might have understood. Thank you for your attention. Thank you. Nandri.